zeroth law of thermodynamics is actually very similar to the transitive property that you may have learned in mathematics. The transitive property states that if a number A equals B, and that number B equals another number C, then you can state that A equals C, which is quite intuitive. Now, let me show you how the zeroth law of thermodynamics relates to this property. What the zeroth law states is that if you have a system that is in thermodynamic equilibrium with another system, so these two guys, A and B, are in thermodynamic equilibrium with each other. What does thermodynamic equilibrium mean? Well, it means that there is no transfer of energy from A to B. Now, I think it's really important that everyone understand what heat energy is. It's actually quite simple. Heat energy is simply molecular motion. It's the kinetic energy of the molecules in the object. For example, if you have two identical bricks and one's hot and one's cold, what's the difference? The difference is the atoms in the hot brick are jiggling faster than the ones in the cold brick. That's what heat is. Okay, so if A and B are in thermodynamic equilibrium with each other, that means there's no transfer of energy from A to B, or another way of saying that is the molecules are jiggling at basically the same rate on average. Now, if we take a third system, C, and we know that C is in thermodynamic equilibrium with B, that is, no transfer of heat energy from B to C, we can then state that A is in thermodynamic equilibrium with C. Do you see how it's very similar to the transitive property? If A equals B and B equals C, then A equals C. The last thing that I would like to say about this is this allows for measurements of temperature with a thermometer. Because if you take a thermometer to A, a thermometer is like its own system, and this thermometer, you stick it on A, right, and you get a temperature reading. In other words, the thermometer is now in thermodynamic equilibrium with A, and you get a reading of temperature. And then you stick the thermometer, again, its own system, on C, and you get the same temperature reading. Thus, A and C are in thermodynamic equilibrium with each other, or the same temperature.